RSA algorithm. This is a basically cryptographic asymmetric algorithm. This algorithm based on two different keys, public key and private key. So before going to discuss about this type of algorithm, what is cryptography? Cryptography basically protect your computer, protect you and your program, etc., from external hazards, external disturbance, hacking, etc. Because it uses encryption and decryption algorithm protect the data from the outside world. Now, cryptography basically two types. One is symmetric, another is asymmetric. In the case of symmetric, one key only there to encrypt, decrypt, that is secret key, and another one is asymmetric where two keys like public key and private key. Public key is used for encryption and private key is used for decryption. Now, the process of the RSA algorithm. This algorithm based on three processes basically is key generation, encryption, decryption. In the case of key generation, you see we take P and Q. P and Q we select that both are prime numbers. Then I calculate P and Q, that is product of P and Q stored into N. And in the xi n or whatever is the xi n, you say equal to P minus 1 to Q minus 1. Now what is I want to do? We actually calculate the encryption, that is public key and private key, and for that I find E as a encryption key and D as a decryption key. Okay, so first we take E for getting the public key. How can I calculate E? We GCD, get the greatest common divisor between the whatever I find from N, comma E, equal to 1. That is, you know, both of GCD, if because it is prime, so both of GCD should be 1. Then I say that it is E, and E should be 1 less than phi n. The same way we can calculate D. D into E mod xi n equal to 1. Later I see in an example on the right side. So D into E mod xi n equal to 1. So in this way we get also D. And we use E in the case of public key and we use D in the case of private key. Now the main motive is that we should um, encrypt the message. Suppose message M or whatever P, plain text message, become converted into the ciphertext. So how can I get ciphertext? Ciphertext equal to M to the power E into mod n. Using this formula we get C. Okay. Here we use E M to the power E mod n. And in the case of decryption, again I come back to the plain text, that is P or C. So M equal to C to the power D mod n. In this way get again getting the plain message by decryption. Now see the example in the right hand side. I take P equal to 3 and Q equal to 5. Both I multiply them and again I multiply in the xi and P minus 1 Q minus 1. Now I find E, before I said that E comma Qn, that should be xi n comma E. Because in the formula we see xi n comma E, so it is xi n comma E equal to 1. So if I take the mod 8 comma 3, 8 comma 5, all are result given the 1, and it should be 1 less than 8. So criteria is fulfilled, so I getting E either 3 or 5 or 7. So in this way we also getting the D decryption key. So D into E mod xi n equal to 1. That I taking from this formula. Okay, this is. So in this case, the phi n or xi n is first. Okay, in the case of E, I write here E comma no xi n comma E. So fine. Now D into E mod phi n. So if I take 3, then 3 into 3 9, 9 mod 8, 1. So also this criteria fulfill if I take the D equal to 3. In this way I get E equal to 3 and D equal to 3. So public key comma n 3 comma 5 and private key D comma n 3 comma 15. So in this way we getting the public key and private key. Now the question coming, how can I encrypt and decrypt through this public and private key accordingly. So I taking the plain text as a P, that I say here M, so you can get plain text P. No problem, this is like a variable. So C equal to P to the power E mod N. This formula, if I put this formula, then I getting the value in this way 2. See, that is hypertext become 2. Plain text 8 become the, I take the plain text as a 8. Here I getting 8. Plain text 8. So this 8 becomes 2. You see, I taking the plain text as 8. Now, if I decrypt this 2 in this formula, c to the power d mod n, 2 cube equal to mod, that is 15, I getting the 8. So 2 cube mod 18, how getting right? Because 8 mod 13, 8 is less than the 15. So always mod that same value again I written as a same value, because 8 mod 15, 15 is greater than 8. So how can I divide 15 and getting the remainder? So 8 is remain same. So 8 mod 15 means 8. 9 mod 15 means 9. 15 mod, whatever say, 15 mod 8, then what is the result? 15 mod 8, that is 7, because remainder is 7. 8 was 8. So in this way, I get come back the plain text again. So in this way, RSA algorithm give us the result of encryption and decryption for public key and private key. Okay, thank you.